afternoon, everyone, and welcome to another NERDIC Tuesday. Here we have an exciting program for the New England Regional Defense Industry Collaboration, Industry 4.0 Readiness Ecosystem. We've previously talked about generative design, augmented reality, additive manufacturing, but here today and following next week, our focus is going to be on model-based definition. So as we for CCAT, and I'll be running through some of our opening remarks with two of our leaders here in Connecticut, Colin Cooper and Eric Fogelman. Colin is our Chief Manufacturing Officer for the state of Connecticut. Eric is from ConStep and an Industry 4.0 evangelist. And then we have our featured technology partner, RAM Engineering, and Mitch Kaminski is going to be here to talk through model-based definition. As well as we always do, we'll be including welcoming comments, questions, and through the chat. So if you look on your GoToWebinar portal on your right-hand side, you'll be able to see that you can insert questions, and we certainly do welcome that. My colleague Liam Wilson from CCAT will be moderating the chat, as well as Eileen Candles. Then we have an exciting featured focus on our demonstration pilot applications, the recap, the call for applications for our technology demonstration projects. So there's, as always, as we do with NERDIC, there's so much going on and so much to do that we want to communicate with you and welcome your participation, all at no cost. So if we could go to the next slide, I will just give you a short, brief recap of NERDIC and what this ecosystem involves. Really, our program is to help those small to medium-sized businesses within the defense manufacturing supply chain to become cyber secure, as well as ready for Industry 4.0 with generative design, all of the things that I had mentioned previously. So getting a model-based enabled enterprise is really the key focus here, as well as delivering results to our workforce and working in partnership with universities, other research entities, the manufacturing, the MEPs, the manufacturing extension partnerships as well, all across those 6 New England states. So we want to be able to have a skilled workforce across the region, leverage best practices across this ecosystem within I4.0. So as we're closing in on our final introductory workshops, we will also then be starting on those technology demonstrations, and so we'll want you to stay tuned till the very end to be able to hear about those exciting opportunities. Of course, we also do have our website, which is ccat.us/NERDIC, and there you can go on to see all of our previous recordings. So if you've missed anything in that generative design, data analytics, additive manufacturing space, we welcome you to go back and tune in on demand. As well, there's those applications for those tech demonstrations, and also all of our partners within the NERDIC ecosystem. So really, it's an amazing collaboration that we have with really strong leadership and partners. And if we turn it to the next slide, I'll have some of our partners come online and join me. With respect to, I'll first be inviting Colin Cooper to say some opening remarks. Again, he's our Chief Manufacturing Officer here in the state of Connecticut.
Well, good afternoon, and thanks, Jackie. On behalf of the New England Regional Defense Industry Collaboration, also known as NERDIC, and the Connecticut Center for Advanced Technology, also known as CCAT, I welcome you to this week's session on Industry 4.0 technologies. I think Jackie did a good job talking about NERDIC. It's a Department of Defense-backed organization consisting of government and private sector representatives from all 6 New England states that are working together to strengthen our region's defense industrial base through advocacy programming for defense supply chain businesses. In addition to this series on Industry 4.0 technologies, last year NERDIC established a cybersecurity training program, partnering with the New England Manufacturing Extension Partnerships, led by ConStep. And in a minute, we'll hear from Eric Fogelman from ConStep. I wanted to pass along my thanks to the CCAT team for developing and launching this Industry 4.0 technology workshop, the series of workshops and demonstrations. The Defense Department is keenly interested in fostering the adoption of new digital technologies in the defense manufacturing supply base. And the first step is an awareness of these technologies and the transformational power that they represent. This session, CCAT, the CCAT has held to date. I've seen a number of them have been, I would say, interesting and informative and led by subject matter experts. And today you've got Mitch Kaminski talking about model-based definition. This work is entitled Model-Based Definition. What is it and how does it help your design and manufacturing process? And I'll leave that to Mitch to get into the details of that question. But I will say that model-based definition really is a foundational technology, digital technology, and it's going to become a requirement for next generation DoD programs. So it's great that you all are tuned in to learn about it today. And as Jackie mentioned, CCAT has additional technology workshops and demonstrations scheduled throughout the summer. So thank you all for participating. And now I'll turn it over to Eric Fogelman at Concept. Eric.
Thank you, Colin. Yeah, Concept is excited to be involved in this movement to help the local small and medium manufacturing community adopt Industry 4.0. You know, we feel strongly that it's not just a way to the future, but it's the way to the future. You know, that's the key to sustainability long-term for any company in manufacturing and technology. But one of the core things that we really want to look at is, you know, not just applying technology for the sake of technology, but looking at the business sense. You know, is it going to help somebody in their productivity and in their operations? And model-based definition, as Colin mentioned, it's kind of a gateway to what's referred to as the digital thread. So that's how you can connect everything from the design and development of a product all the way through the full life cycle to you know, disposal or recycling. So all the information that you need to design, simulate, manufacture, test, and support a product are contained in those models, and that's not only propagated forward through each phase of design, development, and manufacturing, but also devices that get out to the field that are being supported by, you know, either your own personnel or you know, your customer. That information that they're encountering, that performance of that product, can be fed back through that digital thread back to the beginning. So this is going to enable companies to have a much shorter development cycle, you know, drastically reduce your time to market, number one, but also drastically increase your speed to implement customer feedback and, you know, improve your product continuously. So we're really looking forward to, you know, hearing more information today and, you know, getting everybody better educated on what's out there, what the tools are, and what the benefits are for a small manufacturer. So thank you, and I'll turn it back over to Jackie.
Eric, I actually do have a question for you, since you are a certified Siri assessor. So Siri, not from the iPhone, but Smart Industry Readiness Index. I know that I've recently seen on LinkedIn that you've been going out to companies, and having this adoption is certainly a culture change. So I'm wondering if you could share with a broader NERDIC community as your experience going in and really talking to see where companies are and taking you along on their journey.
Absolutely. Yeah, I joke with everybody that I had to change from an iPhone to an Android phone because the amount of times I kept saying Siri. I had my phone asking me what it could do to help me. It's an exciting process. So the Siri, the Smart Industry Readiness Index, is an assessment tool that that was developed by the Singapore Economic Development Board back in 2017, and it's seeing worldwide adoption through a connection with the World Economic Forum. So right now, I'm one of 5 people certified in the North America to conduct these assessments. And we take a pretty good holistic view of a company in terms of their process, their technology, and then their organization. So we look at not just how they do what they do, and not just you know, what tools they have out on the production floor, but we also look at how they're arming their employees to help advance this. And it's meant to be a a long-term transformational process. This is not just picking up disparate pieces of technology and doing one-off pilots. The idea behind this is to really go into a full digital transformation, take a fresh look at how you do things, and make those improvements and set your company up for a long-term success and sustainability. But it's exciting. We've had the first couple rollouts recently, and we're seeing some really interesting things for our local clients. And the insights that we're gaining and the information that we get is really powerful and really helping them to plot out those next steps. And I think that's one of the most beneficial aspects of the SERI assessment. We've looked at a number of different models out there, and a common theme with a lot of them was you'd get done, you'd have your gap assessment, so you knew where you were falling behind, but you didn't know where to start. You didn't know which technologies to start with or which areas to address first. And that's one of the great things with this assessment, is it gives you a prioritized list. Here's where you should start, and here's your roadmap. So we think this is going to be a very powerful tool for this community.
Great. Thank you so much. Absolutely. We're very excited at CCAT because our colleague Christy Oki has gone through all of the training, and so hopefully we will very shortly have a 6, add that +1 with having Christy join Eric here in Connecticut as being SERI certified. So Colin, do you have any final remarks based upon the question that I had answered, that I had asked of Eric, or any closing thoughts? I don't have a direct question for you, sir.
No, that's fine. No, look, we're very excited about this. Eric getting certified. I think Connecticut's really sort of taken the lead here. There's a big focus on digital transformation, and we're trying to get the word out to the whole New England defense manufacturing ecosystem. I think having people trained like Eric is, and really starting to implement this tool is going to be a game changer for us all. So we're really excited with these new developments.
Excellent. Well, thank you both for your remarks and for sticking with us till the end. If we have any additional Q&A, thank you so much. And at this point, I will welcome Mitch Kaminski to join us. He's from RAM Engineering Solutions, and we're just loading up his presentation right now. So Mitch will be taking us through what is model-based definition, and I will be signing off and dropping off. So thank you all for attending. I will just put a reminder that the handouts of the PDF for this presentation are included in GoToWebinar as well. Please ask your questions, and we will be monitoring and having a Q&A session at the end of this program. So thank you so much, and Mitch, take it away.
Hi, good morning, or I guess afternoon. Thank you, Jackie. Thank you for the introduction. Let me arrange a couple of screens here for a moment. And welcome. So today's presentation is Introduction to Model-Based Definition. It should be about 30 minutes long, and I'll try to go through these slides relatively quickly and give us plenty of opportunity at the end for questions and answers. Please feel free to post questions into the chat or the questions area, and we'll try to get to them at the end of the presentation. Today's presentation is a prelude. I think it was mentioned, I think Jackie or Don had mentioned that there's another presentation going to be in another week or 2 weeks, 6/22. And that'll be a more in-depth look at model-based definition. Today is an overview presentation. So I'm Mitch Kaminski, president of RAM Engineering Solutions. We provide CAD support services for the aerospace and defense industries. We specialize in tool design to eliminate setups, tool design for cost reduction in manufacturing, and tool designs to enable cost reductions utilizing emerging or advanced technologies. Some background on myself: I've been a manufacturing engineer for 25 years. I've been running RAM Engineering Solutions for the past 12 years. I've been a SolidWorks user from its inception in 1997, and I hold a CSWP, or Certified SolidWorks Professional Certification, from Dassault Systems. And with me here today is Steven Bukowsky. He's one of our lead design engineers. He's also a mechanical and manufacturing engineer for about 12 years now, and he also holds a CSWP and has been using SolidWorks since about 2004. Actually, most of the people on our team are all CSWP certified. So model-based definition, or MBD, what is it? MBD, or model-based definition, in its most basic form, hold on, I gotta move a couple things here. Its most basic form is putting product and manufacturing information on or within the CAD model itself. On the bottom left is a 3D model with MBD on it, and on the bottom right is the same 3D model shown in a 3D PDF. For this presentation, the application and use of MBD within the model is what we're going to be focusing on. The upcoming presentation that I mentioned earlier is when we'll do a deeper dive into MBD modeling in the 3D PDF that you see on the right-hand side. So it's worth noting here that MBD can be much, much more, as Colin had mentioned and Eric had mentioned. It's more than just putting MBD or PMI on the model. MBD can be thought of as the cornerstone or the foundation of a much larger paradigm-shifting digital transformation of an organization to become a smart manufacturing facility. MBD can be thought of as the impetus or the reason for an organization to begin its digital transformation, a transformation towards becoming smart manufacturing. Ultimately, it's going to be a shift away from, and in some cases, separate legacy business systems towards a completely connected digital system. A digital system, or as I think Colin had mentioned, a digital thread, from when a job is quoted all the way through to when a job is shipped and everything in between. So some advantages of the digital thread. In its simplest form or application, adopters of MBD are reporting time savings. Specific numbers are available, but they really usually seem to be relevant to a particular case, particular process, or a particular business. In some cases, some of the reports that DoD did earlier in the 2013s, 2014s are 200 some odd pages long. But the bell curve of that data, once it's plotted out, people are seeing anywhere between a 10 to 30% savings. That's a time savings. Some cases, companies are seeing the time savings just on the drawing portion, as shown here with the model and the drawing on the left-hand side, versus the combined GD&T model on the right-hand side. And that's probably the simplest and easiest metric to capture is the drafting side. But it can also be one of the most frustrating and challenging to implement. But it's definitely the easiest metric to capture. The real benefits of MBD are realized in two additional ways, and that is in the reuse of that data and the consistency or accuracy of that output. With regards to the reuse of that data, I'm referring to how often that a certain piece of information is used downstream. It's a much more difficult metric to capture. For example, it's very difficult to capture how an operator does not have to look for a particular dimension or tolerance on a drawing, or for when a computer or CMM can read the model and know the tolerances without the operator having to put them into the system. With regards to consistency or accuracy of the output, I'm referring to features being misinterpreted. For example, a radius or a fillet call out on a unless otherwise specified note, or perhaps it's a hole that's meant to be a through hole, but wasn't machined that way. And that's the most classic example that you see about in most of the reading is about a hole that was meant to be through and wasn't, and as a result, you're into the scrap area. Those two benefits are why the DoD started the digital transformation. At about this time, it's been about 15 years since they started that digital transformation. And today, the tools are finally being available and connected in such a manner to enable work to be sourced globally. Major manufacturing companies are already using MBD, either internally or in their supply chain. We're certain there's many more companies that are using MBD than we've been able to gather and show here, but we know the companies that would be the most familiar. What's become understood when doing that research and collecting this group of companies is that the larger the company, the larger the digital transformation. And that newer companies that are starting themselves up are already starting themselves up as being model-based enabled. So it points to the conclusion that there's an immediate need for already established mid-sized companies to implement MBD and to begin their digital transformations. We know from past experience that the bigger the company, the bigger the transformation, the more time and money it'll cost. So adopting it now enables you to save money sooner. And a colleague of mine, 20 some odd years ago, coined the phrase, "It'll never be cheaper than it is today." And over the course of my career, it's amazing how ironic that statement has become, but it's certainly applicable here. The sooner an organization can start, the sooner they can save. It's probably also worth noting here that the sooner an organization can start, the further they can distance themselves from their competition. Shown with the blue downward pointed input arrow, how a part or model is presented or given to a company is a topic of a presentation in and of itself. For the scope of this presentation, we're interested in the basic manufacturing process, shown with the numbers 1, 2, and 3. We're really interested in how a model is managed within a company or within an organization. And no two companies will manage a model in the same way. It will all be particular to their type of business. So we're interested in the ability to model something, make something, and to inspect something. In the case of RAM engineering, tooling being our wheelhouse, the ability to model a tool, to make a tool, and to inspect a tool. Here's an example of a simple gauge designed in SolidWorks and with MBD applied. In the case of SolidWorks, version 2015 and up support model-based definition. And again, in the case of SolidWorks, version 2017 and up support AP242. AP242 is a CAD neutral format for moving models with embedded PMI data between MBD-enabled systems. Approximately 2016 is when AP242 succeeded AP203 and 214, all three of which are better known by their step designation, Step 242, Step 203, and Step 214, respectively. So again, just to reiterate, 203 and 214 are no longer being supported. All of that development energies are being put into Step 242. And AP242 or Step 242 is supported by all the major CAD, CAM, and CMM softwares. And even other CAD, CAM softwares, they all have roughly about the same timeline of capabilities. Being competitors, they're all implementing the same solutions at about the same timeline, with plus or minus a year. Here's an example of the same gauge being machined in Mastercam. In the case of Mastercam, which is widely used across several of our customers and in this area, New England area being where it's headquartered, 2016 and up support MBD and AP242. As an example of what I mentioned earlier on an earlier slide about the tools being available and connected, nearly all packages support tolerance-based machinery, or TBM, to automate much of the toolpath programming. What we're seeing here is SolidWorks running separately, Mastercam running separately on this gauge, but it can also be run within SolidWorks itself. And many of the CAD systems are starting to integrate together, enabling them to be able to read the Step 242 information. Here's an example of the finished machined gauge. In the center picture, I couldn't show the part here, but the center picture shows a center bung with 3 dimples around it. The part sits on those 3 dimples, so those are datum surfaces. And to the left and to the right, you see basic trim. And to the foreground and the background, max trim. So in this particular case, the piece of sheet metal is machined a hole in the center, and there's the left and right are bent up, and the forward and back are bent down. And the gauge needed to be accurate so that we could measure the machine lip of each of those 4 surfaces, forward, back, left, and right. Here's an example of the gauge being inspected with Verisurf inspection software. In this example, Verisurf was able to import the MPD data and compare or overlay the scan against the model with tolerances and able to produce the color map of the areas in and out of tolerance. Most modern CMM packages are MBD enabled, having the ability to read many of the most common native CAD formats, but also AP242 or Step 242. As with the case of machine toolpaths on a previous slide in Mastercam, the inspection scan results are also savable to a product data management system or a vault for addition to a technical data package. So in this particular example, this is a gauge, but it could very easily be a machine component, whereby this scan data would represent part of the technical data package required by the customer. So as a summary to the basic manufacturing process, We can model a part and apply MBD. We can make a part or a tool and apply the MBD. And we can inspect a part or a tool using the same MBD data. And again, not to reiterate or intending to reiterate and to tie in with an earlier slide about reusing the data, we're able to reuse the MBD data that we applied at the model level in all of the downstream manufacturing processes. Something that should not be overlooked is the revision control system. If a tolerance was changed on an initial lot, for example, the PDM would automatically catch the revision and subsequent operations are either flagged for review or in the best case scenario, they are automatically updated. In the case of a tolerance not being changed, but a revision control, which is something else that that is vitally important, is being able to make sure that we have the right revision on the floor. The PDM system would be able to identify which surfaces have changed, and then either again flag them for review, and in the best case scenario, actually revision control the toolpath programming to make sure that the right product is made. And no conversation or discussion about MBD can really be had without being aware of the MBD readiness scale. Referring to earlier slides with some of the major manufacturers already being MBD enabled, early adopters have been doing MBD for over 10 years, close to 15, depending on what aerospace manufacturers we're talking about or identifying. They're able to maximize the benefits of MBD and the digital transformation on a global platform. This is why we see the likes of Boeing and Airbus and others focusing their efforts on the enterprise level of the scale, which is levels 5 and 6. They are working on the digitally linking their smart manufacturers to their system for real-time data throughout their global supply chain. And although we have a very robust manufacturing base here in the New England area, there's a technology gap within the supply chain that needs to be closed in order for us to win future work. Levels 5 and level 6 are model-based enterprise levels. You can see levels 4 through 0 are all model-based definition levels. So when you get to levels 5 and 6, it's really the connection or the digital connection of the entire manufacturing system that I mentioned earlier about being from quoting all the way through shipping. And I'd like to open up the floor for some questions and answers.
Hi, Mitch. This is Eileen Candles back on, and hello to everyone today joining us for this presentation. It's my honor on behalf of CCAT to introduce Liam Wilson, who is a UConn engineering student and an intern at CCAT this summer. And Liam is gonna join us for the Q&A. So Liam, the floor is yours with Mitch. Thank you both, and Mitch, thank you.
Yes, well, thank you, Eileen. Yeah, so we'll get right into it, Mitch. I mean, there's a lot of talk about how you can start and you're excited, you want to get into it, but what are those first steps that you can do to get started with this?
Well, the first step is honestly, it needs to be a strategic decision based on the company leadership. And very similar to ISO certification, 20 years ago, it really needs the support of the management. So that is first and foremost, understanding what the strategic benefits and the strategic positioning of becoming model-based enabled really is. Outside of that, once there's already management support, in most cases, getting started is relatively straightforward. Most of the systems you probably already have the 3D PDFs that we had mentioned earlier that we're going to talk about in a subsequent presentation. The reason that DoD picked Anarch to develop those features for Adobe Acrobat is that it's widely available and it's being produced. It's on everybody's phone or everybody's computer. So the tools are really out there to facilitate easy adoption. More than likely, you have many of the tools already either in the CAD systems or in your IT systems, or again in your manufacturing systems.
Awesome. Well, that's great that the tools are so widely available. Another question here is, can MBD inspection be done with CMM and structured light? Can you just elaborate on that?
Good question. So in this presentation, we use structured light, but CMMs are more widely available. So yes, it can be done. There are some very old CMM systems that are not NBD enabled. Those obviously will have a difficult time. Not that it can't be done, but there's probably some patches that could be done. But most of the modern CMMs in their software are 242 enabled. It just won't give you the color meshing that we saw in the example. So you'll pick up points, and those points will be back onto the model, and then you'll be able to color map from those point clouds, if you will. So yeah, CMMs are perfectly adaptable to AP242 or to NBD.
Oh, that's good. That's good. So just another question, kind of similar, but can native file formats be imported into NBD?
Yes, obviously staying native is going to be important. And as I mentioned on that earlier slide about the blue input arrow, various customers are going to be able to send you their file formats, and even within those customers, we have seen that different divisions within that customer will have different NBD requirements. So that is to say, there's always going to be some type of unique solution that's going to be required to make sure that that data is coming into your organization and all that PMI is on the model. But what's important is that once it's inside your organization, that you're able to do its life cycle from beginning to end. Now you might be on one of your customers' CAD systems or not. One thing that we've seen through the manufacturing supply chain is that bigger organizations, they can afford to stay on some of those CAD platforms, but we know that as the chain goes down, that they need to find more economical ways of ensuring that data is flowing down to those suppliers. So there's always going to be some type of translation either on the front end or within your own supply chain beneath you. But yes, in most cases, just about all the major CAD platforms have some manner of importing native geometry, native CAD form. There's always convergent softwares out there, but I think you're probably going to start to see. We've seen that a little bit already. Some of those convergent softwares are being adopted by those major acquisitions, being bought into those CAD platforms, and that trend may continue.
Okay. Yeah. Well, that's awesome. As of right now, it doesn't appear we have any more questions. So,
Nice.
But feel free to put them in the questions or the chat, and I'm sure at the end, Mitch can answer it. But I think I will turn it back over to Eileen now, and she'll go through a few more slides.
Great. Thank you. Thank you, Mitch. Thank you, Liam.
Thank you.
Again, you got it. So as was mentioned earlier by Jackie, we invite you to participate in the many pilot projects that the NERDIC organization has going on now. We are accepting more applicants for the generative design pilot programs, and you'll see on this slide here the qualifications to apply. So you do need to be a New England-based defense supply chain company with at least 5% of your sales in one of the last 5 years to DoD. We will review any applicants for selection, and if you do have something that is ITAR or export controlled, we can offline that with you and have a separate discussion, as the pilots that we are selecting for the NERDIC program are to be presented in the demonstration technology pilot presentations, which follow starting June 22nd and through this summer. So we want that information to be able to be publicly shared. And again, we would review that with you for any and all of the applications. Could go to the next slide, please. So as I mentioned, we are still accepting applications for the generative design part optimizations, and those pilot applications will be selected for manufacturing to be done either by CCAT using additive technologies, or the Berkshire Innovation Center, or University of Maine and their Center for Advanced Additive Manufacturing of Metals. And if the design is too big, a scaled version will be printed and will be shared in the demonstration pilot webinars. Again, and those generative design pilots will be held throughout the month of August. We are accepting those applications now between now and the end of June. First come, first served, but we do have openings for more, and we really would love to see representation across New England. So if your company is one that would be qualified, please feel free to submit. If you know of someone else, please pass this information on to them and share it on your social media so we can get this message really amplified throughout New England. One other point I will make here too is that there's funding available. If you could go back to the last slide, perhaps, there's funding available for all of these programs across New England that many of your MEPs could make available to you. So for example, if you want to invest in some of the industrial Internet of Things applications to this new digital thread technology, as Mitch has shared today, there could be programs available in funding or matching funding available through your state. Here in Connecticut, for example, CCAT is administering several programs, including the Industrial Internet of Things Integration Voucher Program, and you could find access to that on ccat.us/programs website. And we also continue to have the Manufacturing Voucher Program, which provides matching funding up to $49,000 for an acquisition of a new advanced technology. So again, we welcome you and encourage you to both check with your own state's MEP to see if there's funding that can help you adopt and advance any and all of your technologies. So now I'll move ahead to some of the upcoming events. Next week will be the last of our introductory webinars, and we will have Renishaw speaking with us on machine tool probing for Industry 4.0, showcasing some of the many technologies that are available and what machine tool probing can do to save your organization time, effort, and money. And then following that, we will begin the kickoff of all of the technology demonstration presentations. Those will run over the course of these 7 weeks listed, starting June 22nd and going through the end of August. And so, for example, Mitch will be back on June 22nd with Stephen Bukowsky to provide a more deeper dive into model-based definition and really walk us through an example in that presentation. And on July 13th, Renishaw will return to do more deeper dive into machine tool probing. And on the 20th of July, we will have Stanley X and the Deep How technology back to demonstrate for us the application of this advanced smart how-to video technology across a number of companies that are across New England. So we will be hearing from Darn Tough from Vermont. We will also be hearing from Hubble Electric here in Connecticut, and another organization in New Hampshire. And then on July 27th, SphereGen will return with augmented reality. And again, we'll hear from the voice of the customers who participated in the pilot programs with using the SphereGen augmented reality and the HoloLens to adapt and look at both their remote share and remote troubleshooting, as well as apply to learning of new processes by their workers. And then throughout the month of August, we'll be hearing the generative design presentations, and we'll be witnessing how these pilot programs were adapted for the different participating companies from across New England. And those will be led by Jeff Crandall from CCAT, along with Nasir Manin. And also we will be hearing from the University of Maine, the Center for Additive Manufacturing of Metals, and Vermont Manufacturing Collaborative, affiliated with the Vermont Technical College. And then also from Berkshire Innovation Center, partnered with the Mozalic Group and Roundabout Consulting. So for any and all of those, you can register at ccat.us/NERDIC. And we invite you to visit that website for lots of information, as well as information on some of the prior webinars that have been held. You do not need to have attended the introductory workshop in order to come to the technology demonstration workshops. There will still be a very brief kind of introduction and overview of each of those technologies prior to the deeper dive into what does this mean? What were the advantages that were explored? What were benefits gained and achieved? And how could that then be taken and used to apply to your company? So with that said, I wonder whether Liam, if we had any other questions that popped in. I'll assume no, unless
Yes,
well,
we
there you are.
did. Yes,
All right,
we have
great.
some more. So Mitch, if you want to hop back on, we do have a question about the old school work and how to get tools. Basically, the question really is we have old school workers that like to work with the blueprints, the drawings, like the paper. How do we get them the MBD so that they can use it and they can build effectively too?
Transition process. So there's a bit of a I'll keep it short, but there's a bit of a process to how to bring those legacy type practices into the modern age. We kind of got into MBD by doing hybrid drawings for our customers, and that's probably the best place to start, is bringing the engineers online. One of the ways that you could do it is you bring the engineers online, they become skilled, and then you start doing hybrid style drawing. So behind the drawing, the 2D drawing is all MBD generated, and then you can slowly transition again through that technology gap that we talked about before. Start to see what technologies you need to implement on the floor so that they can begin to use some of the 3D PDF stuff. So it's transitional, and I'll let Steve take a stab at it as well.
Yeah, you more or less covered the basics of it, but it's one of the questions that's going to have a unique answer depending on your particular organization, your workers, your machines. But just because you have something done in MBD does not mean that you can't also generate two-dimensional drawings and physically print them out if necessary.
That's correct.
It's just that your workflow maybe doesn't require you to generate drawings except in cases where a part is specifically going to have an operation done on a bridge port, in which case you can take your MBD part and very quickly generate a 2D drawing from that part because all of the dimensional information is already there. Another thing to keep in mind too is that because all of the dimensional information is there, you can put maybe one of your lower skilled intern or one of your newer engineers on the task of generating the 2D drawing from that part because there's no actual engineering or tolerancing that needs to be done on it. All that information is already there. So that's another way where there's a reduction in the overall cost of everything because you keep your higher skilled guys doing the higher skilled work and not doing the drafting work that they might otherwise have needed to do previously.
Yeah, it's worth noting, I think Steve said it really well, that just by going to MBD and going to 3D PDFs is not paperless. It can be, but it doesn't necessitate the need that everything needs to be paperless. In many cases, you can print the 3D PDFs and you generate the views that you need for your particular floor. As Steven said, there's more than one answer. Not one answer fits every single particular organization. And even within divisions within the same organization, one unit or one cell can be working completely different than a different cell within that same organization. So there really does need to be a unique solution for each type of division.
Yeah. Well, I think that would do it for the questions. So thank you very much, Mitch and Stephen. I appreciate it.
Thank you so much. Very much appreciate it presenting. Thank you.
Thank you. Thank you. So at this point, if Colin or Eric wanted to come on with any additional comments, you are certainly welcome to join back in. But otherwise, we might be ending today a little bit sooner and giving everyone some time back to your own day. We would appreciate your feedback on the brief survey that will display after this webinar ends. So thank you for that. It helps enable us to develop stronger content as we go forward. And Nasir's email is there as well as our program lead for the NERDIC programs. Hi, Eric, welcome back on. And if there's any additional comments you'd like to make for our audience, I know you're driven towards continuous improvement as you are, Colin, and all of our manufacturing partners. And it's just exciting to hear of these new technologies and get more information, but also know you can return to even learn more, right? So the floor is yours.
Yeah, I just wanted to kind of follow up on a couple of the comments that were made. We've talked about, especially in the context of the defense industry, that this is something that's coming that will be a requirement. So there's obviously a big push to need to adopt that to stay relevant and keep a seat at the table, so to speak. But beyond that, we had really kind of touched on some of the things, the benefits, the business benefits that come from this. And like I said, that's where we kind of start and end every conversation that we have with anything, whether it's with respect to continuous improvement or lean, or whether it's with technology. It's got to make business sense and it's got to be driven by a business need. So some of these numbers about, reducing the time, even just in the drawing phase, reducing the time by 10 to 30%, the ability to reuse pieces that you've created, the ability to just streamline that process of propagating the information from one step to the next. There's a lot of tangible business benefit, and there's a huge upside to investing in this and streamlining your own processes, saving a lot of time, saving a lot of mistakes. We see this all the time where when you create the drawings from that 3D model, you might forget someplace where you've put a dimension in a drawing, or you might forget to change a reference somewhere. So this whole process streamlines a lot of those pieces and saves a lot of wasted time and wasted energy. So instead of finding that issue after you've produced a part and you go to inspect it and then you have to scrap everything, you catch it early on. So again, from the idea of having that benefit to your business, not just because of the regulatory piece, but keeping yourself, not just productive, but competitive in your market, and being able to offer something that other people might not is a huge drive to adopt this as well.
Great points, Eric. All great points.
I'd like to add one thing. I want to thank you for these workshops and demonstrations. The adoption of digital technology is a bit more difficult, I think, than adopting sort of more traditional technologies. All of us who've been business owners, it's pretty easy to look at a new piece of equipment and look at the increase in speeds and feeds and sort of do the math on how that's going to generate a return on investment. It's a bit more nebulous with these digital technologies. So the first step is really an awareness of what's out there. And then the second step is really an understanding of how that gets applied. So I think the workshops and the demonstrations are key for that. And again, I kudos to all the business leaders out there who are sort of tuning in and becoming aware of this. These are transformational technologies. It's just they're different than what we've done before. So there's an awareness factor. There are going to be challenges with applications. We turned the question to Mitch on how companies adopt this. Every company's going to adopt differently, but the first step is awareness, and then the second step is trying to understand how that can impact your business. And these workshops and demonstrations are critical to that. So thank you very much for hosting this series of events. And I look forward to the next model-based definition demonstration in a few weeks. So thank you.
Thank you so much, Colin, and we look forward to having you come back. And as always, thank you for your leadership across the state of Connecticut, and together with your NERDIC steering committee partners across New England, driving this information and helping making it accessible and available for free, as Jackie pointed out earlier, to everybody that's participating now and who might participate when they hear more about everything that we have available on demand, and by helping spread the word even on your social media. So thank you so much, Colin, and thank you again to everyone today for participating. Mitch and Stephen, we look forward to your return in a couple of weeks and the information with your deeper dive into model-based definition. And to everyone who's participated, thank you again so very much. Have a wonderful day. Bye.